Hello friends! In continuation of the instructional videos about the LS brand M100 inverter, today we want to talk about the errors that might occur in the M100 inverter, what these errors actually mean if they appear, and how we should go about resolving them. The errors that occur in the M100 inverter, the first error that the M100 inverter displays is OLT. OLT stands for overload. This happens when we set up the inverter, so that when a certain percentage of the rated current is drawn from the inverter, or when our electric motor draws that current from the inverter will display an error for us. If the current exceeds the percentage we set for overload trip in the parameter settings, the inverter will give us an overload trip error and show us that we're drawing more load than the capacity we set. This means that our current draw has exceeded the threshold for overload trip, or in other words, it's an overload trip. This means the load we're using right now, the load on the electric motor shaft, is more than the capacity we set. Now, October, or overcurrent, happens when the inverter's output draws more than 200% of the rated current, right? The inverter gives an OCT error, or in other words, an overcurrent error. The out related to overvoltage happens when the DC link voltage goes above the allowed limit, and the inverter gives an overvoltage error. When does this happen? We get an overvoltage error when the inverter's input is higher than the set limit, meaning our line voltage is too high. Or during stoppings, if your stopping time or deceleration time is too short, the inverter will issue an overvoltage error. Another possible reason could be related to your electric motor, if the insulation or the winding of your electric motor is damaged. It's possible that this inverter gives an overvoltage error or an LUT error, which is the same as a low voltage error when the DC link value drops below the allowed limit, below the value set in the inverter or by the factory itself. If it goes lower, in this case, the inverter will give an LUT or low voltage error. This happens when your input power, the input to your inverter, drops below the allowed limit set for the inverter. The next error, GFT, ground fault, occurs when either the output of your inverter has a problem, the inverter itself is damaged, or it could be due to issues with your output wiring. There might be a ground connection somewhere, or there could be current leakage or a short circuit, or the third reason could be something else. Damage to the motor insulation. But the next error is ETH, or ETH. This is the motor's overtemperature thermal error. Depending on the settings you made in the protection group and the correct rated current you set. If it goes beyond this limit, it will give the ETH or motor thermal error. OPO is the next error, which is related to output phase open. If one of your output phases, U, V, or W, gets disconnected in the inverter, this error will show up, so you realize that one of your output phases has been cut off. But the next error, IOL, is related to drawing too much current from the device itself. This is the inverter. Your inverter, based on the nameplate it has, specifies a rated output current. If you draw more current than what's written on the nameplate, the inverter will give an IOL error, or the inverter will trip due to overload. It means it's telling you that you're using more than the inverter's capacity, right? You're drawing more current. If this kind of error appears, it means you've used more than the inverter's rated current. You've drawn more, and now the inverter is giving an IOL error, but the next error is related to the rotor. What does that mean? If you see a rotor error on the M100 inverter, one reason could be damage to the inverter itself, meaning there's a hardware issue with the inverter. Another reason could be, as they say, electrical fluctuations or impurities in your input power. In other words, your input power is unbalanced, or in your input electricity. You're experiencing fluctuations and the inverter is giving an input error, meaning there's a problem with your inverter's input power. As we mentioned, another reason could be related to the inverter itself. That is, the inverter might be damaged and have a hardware issue. but the next error is OHT. If your inverter overheats and is in an environment where proper cooling isn't happening as it should, and if the IGBTs in your inverter get hot and overheat, the inverter will give an OHT error. This means that the environment where the inverter is operating right now isn't suitable for it, and it needs to be cooled. The next error is NTC. NTC is related to the inverter itself, meaning the IGBT of the inverter might be damaged. Many times, it's a hardware issue. The next error is the fan error. The fan error shows up when the time set for the device's fan on the inverter has run out. For example, if the allowed limit for the device's fan is 1 year and it goes past that limit, the inverter will give a fan error and the fan needs to be replaced. The next error is ETA or ETB, which is external trip. If you configure one of the digital inputs as an external trip, and this digital input is activated, this input will trigger an error for you. It tells you that an external error has occurred and you need to resolve it. But the next error is a communication error. If the connection between the CPU and the main board is cut off for 500 milliseconds, this error will appear on the inverter. Or if the main board of the device is damaged, you will see the following errors. If your stop method is through brake control, MBR, based on the settings you've made, if the current drawn is below the limit you set, it will be lower. So MVR errors are related to brake control, but hold and ERRC are also related to the IOP board. It means that the I/O board of your inverter is damaged and needs to be replaced. So we learned what types of errors appear on the AMSD inverter and what they are related to. What are they related to? And if these errors appear, we can make some adjustments or take actions to clear the inverter error, or not. So now we are fully familiar with the trips and errors that occur on the AMSD inverter.